What's up, everybody? All right, who's excited to do some derivatives? I know I am. Okay, you guys. Let's see. I'm going to go over all of these at hopefully a pretty good pace so you guys can understand and see what I'm doing. All right? Okay, find the derivative of this. Well, the first thing I want to do actually is, we already talked about, we know what the derivative of cosine is, but to take the derivative of 1 over x squared, I'm going to write that as x to the negative 2. To take the derivative of 1 over x, I'm going to write that as x to the negative 1. That's plus, that's minus. Okay? Here's my derivative, right? The derivative of cosine is negative sine. The derivative of x to the negative 2 is negative 2x to the negative 3. And then the derivative of negative 1x to the negative 1 is positive 1x to the negative 2. Now remember we talked about on a multiple choice test, right? You might see it like this, or you might see it written like this, and you just have to check and see which way that they're going to write it. Whoops, let me go back and put that as 1 over x squared. Okay? All right, now, for this next one, okay, you guys know we can find the derivative here. 2 is a constant, so that's going to stay in front. And we have our trig derivatives, okay? Kind of talked about this already. These are going to be on the board for you when you take your test. Let me just pause this and go ahead and write them down real quick. Okay, so here's a list of all our trig derivatives. This is basically something that we're just going to memorize. You know that we can go back through and, re-evaluate tangent, cotangent, secant, cosecant, but it's easier to just have these memorized, okay? Okay, so the derivative of tangent is secant squared. So derivative of tangent is secant squared. Now I need to find f prime of pi. So I need to find secant squared pi. Okay, this is where your trig chart is going to come in. So you guys all have a trig chart. Looks like this. Erase the writing I've done on it here. All right, and let's talk about how to find what we're looking for, like secant of pi. Okay? Okay, so the first thing I'm going to do is I'm going to look for cosine of pi, because secant is the reciprocal of cosine, right? And for cosine of pi, it's the x coordinate, and it's right here. So the x coordinate is negative 1. Okay, so now to find the secant of pi, well, it's the reciprocal of that. If you think about that, what's 1 over negative 1? Well, 1 divided by negative 1 is negative 1. Now I need to do secant squared pi. So I'm just taking that and squaring it, which gives me 1. Okay? So secant squared pi is 1. I'm getting all that from my trig chart. So I come over here and I say, okay, this is 2 times 1, which is 2. All right? Okay, now we talked about the definition of the derivative. Okay, those are the ones that are like a huge, massive pain, but we were still able to do derivatives by doing this. Limit as h approaches 0, f of x plus h minus f of x over h. So before we learned derivative rules, we were doing it that way. All right? Okay, now when I go and plug in x plus h here and x plus h, I get x plus h to the third minus 4x plus h minus x to the third minus 4x all over h, okay? So look, this part right here, this is the f of x plus h. This is me plugging in x plus h to that, minus f of x, so it's minus the original over h. Notice, because this is something easy to miss, all right, these two go h approaches 0, these go as x approaches 0. Okay, well, it's definitely not as x approaches 0, it's as h approaches 0, and then we just look at which one matches up, and it's that one. All right? Okay, perfect. One of the things that you want to know, as soon as you hear average rate of change, I want you guys to think of slope. Now, there's two ways to think of slope. You can do y2 minus y1 over x2 minus x1, which is kind of how we did it when we had 2 points, right? Or we could do f of b minus f of a over b minus a. It's the same thing, but I guess that makes a little bit more sense to me if I have, like, I call that a and b, right? Now, let's plug those in and see what I get. If I plug in 0, okay, let's start with that. If I plug in 0, I get e to the 0 minus the sine of 0. Well, e to the 0 is 1, and to figure out what sine of 0 is, I'm going to go back over to my trig chart. Let's see, sine is over here, or sorry, excuse me, 0 is over here, and sine is the y-coordinate. So sine of 0 is 0, okay? So I go to the angle 0, and then I find the y-coordinate, which is 0. All right. So that's 0, which means f of 0 is 1. Okay, now I'm going to find f of 1. So it's e to the 1 minus the sine of 1. Now, sine of 1 is not a thing. Like on the chart, it would have to be sine of pi over 2 or sine of 1 pi or something. Sine of 1 isn't a thing. So we're just going to go ahead and say that that's e minus sine 1. Okay? Now watch when I put this all together. If I'm going to go f of 1 minus f of 0 over 1 minus 0. Okay, f of 1 is e minus sine 1. F of 0 is 1 over 1 minus 0. Well, if I have a 1 on the bottom, it's just going to be e minus the sine of 1 minus 1. I mean, all over 1, but that's it. And that would actually be one of your multiple choice answers. You can't really simplify more than that. All right? Okay, number 5 is super tricky. When I look at this kind of stuff, guys, I always am thinking about, like, okay, what do I know? What do I know? All right, well, it gives me an equation for f. So I know what f is. And it tells me that g prime is 1. I'm looking for g. And then it gives me this, which I'm like, what the heck does that mean? Okay? But that seems like that's kind of the key to the problem. So let's take a look at what the heck does that mean. All right. Boom. Okay, so this notation is saying I'm multiplying f by g and I'm taking the derivative of it. It would be the same thing as if I was saying, like, derivative of f times g. Okay, so that's just notation. And I know that f times g is a product rule, right? So I would go derivative of the first times the second plus first derivative of the second. And what does this tell me? Okay, this is telling me that at 1, when I evaluated that at 1, it equals 6. Which means if I do f prime of 1 times g of 1, if I do f of 1 times g prime of 1, it's going to equal 6. Okay, so I've got 4 different things here that I could fill into this equation and see if I can get 6. So let's just kind of look through and see what I can find first. G prime of 1, that's right here. That was negative 1. I'll work my way backwards. Okay, f of 1. Now, I wasn't told what that was, but I do have an equation here that I can use. So f of 1 just means plug 1 into f. So this is going to be 1 over 1 minus 2, which is 1 over negative 1, which is negative 1. Making my way backwards. G of 1. Now, that's what I'm looking for, right? So I'm not really sure what G of 1 is. That's like what I'm trying to find. But f prime of 1. Okay, this one's a little bit trickier, but it basically says what's the derivative at 1, right? Okay, well, let's come up here and let's take the derivative of this, all right? I'm going to, like, do this down here for you guys. Now, we talked about how to tell whether you should do a quotient rule or a chain rule, okay? Now, I have an x on the bottom, but no x on the top, which tells me it's actually easier on this to do chain rule. I'm going to write this as x minus 2 to the negative 1, because then my derivative is negative 1 x minus 2 to the negative 2 times the derivative of the inside. Now I still have to do chain rule, but the derivative of the inside is 1, so it's not, going to change my value here or anything. All right, so this turns into negative 1 over x minus 2 squared. That's what f prime of x is, okay? So what was I looking for? I was looking for f prime of 1. I'm going to plug this in. All right, and I'll get like negative 1 over negative 1 squared, which is negative 1 over 1, which is negative 1. There is a dang lot of negative 1s in this. And that all equals 6. All right. So can I figure out what g of 1 is? Okay, let me make this into an equation. Negative 1 times g of 1. Negative 1 times negative 1 is 1 equals 6. So if I were to solve this, I'd subtract 1 over. Oh my goodness, I'm running out of room. Okay. All right. Divide both sides by a negative. So g of 1 is negative 5. So crazy. Okay. So you guys, this is the type of question, like this is one of the hardest questions you'll get, right? I was talking about this a little bit in class. There's like, okay, relatively easy, nothing in calculus is easy, but easy, medium, difficult, right? This is a difficult question, okay? This is a very difficult question. This is the difference between someone getting a 4 on the AP test and a 5 on the AP test. You know what I mean? All right, sweet. Let's go back to a couple of kind of easy ones here. Okay, this is a chain rule. I can tell because it's a function inside of another function. And remember that when we do chain rule, we go bring that down in front, so it's 7. Now, leave all of that the same to the 6. Okay? And then we're going to multiply by the derivative of the inside, and the derivative of the inside is 4x. All right, which I can then go ahead and combine the 7 and the 4x to make it 28x. 2x squared plus 5 to the 6th. All right, so that's going to be a chain rule. For number 7, I think I will probably also do this as a chain rule. Okay, because remember, if there's only an x on the bottom and not the top, chain rule is a little easier to do. I'm going to bring this up. Okay, let me rewrite my original problem. I don't have like a ton of room here, but okay, so I'll rewrite it right here. It's going to be negative 1, and as I bring that up, it's going to be x squared plus 1 to the negative 1/2. Okay, so all I did right here was rewrite. I haven't done anything yet, right? I rewrote that. Now I'm going to do a chain rule, okay? Call it y prime or call it dy dx. All right. Bring this down in front. It gives me positive 1/2. And then when I subtract 1 to the negative 3/2. And then don't forget, the very important part of chain rule is multiply by the derivative of the inside, which is 2x. Now look, when I try to come up with a good answer for this, a nice simplified answer, do you guys see that the 1/2 and the 2 will cancel out? Okay? So I have x, and then I have x squared plus 1 to the 3/2 back down on the bottom. And so that's definitely going to be this one. All right? So that was just like kind of a little complicated chain rule. Okay. Ooh, let's look at number 8. So crazy. It's actually not that bad. Here we go. First, let me find f prime of x. Okay, another chain rule. We know the derivative of sine is cosine. We're going to leave all that the same. And then the derivative of the inside. Now, remember, pi is a number, so whenever I see it and I'm trying to think about how to do the derivative of it, a lot of times I'll like okay, I'll think of it as like x squared plus 3 or something, you know? Okay, so I'm going to go, the derivative of x squared is 2x, and the derivative of pi is 0. All right, so this is my derivative. Now I am going to plug in the square root of 2 pi. What even is that? Let's just plug it in and see what happens. Okay, so it's going to be the cosine of the square root of 2 pi squared plus pi times 2 square root of 2 pi. Ooh, that's crazy. All right, I'm going to work with this for a minute. The square root of 2 pi squared, right, would just be 2 pi. And then 2 pi plus pi would be 3 pi. All right. So if I can go figure out from my chart what the cosine of 3 pi is, I am chilling. Okay. So here's my trig chart. 3 pi. All right, you guys, check it out. 0 pi, 1 pi, 2 pi. So over here would be 3 pi. Okay, 3 pi is the same as pi because it goes by pi every half rotation, right? And cosine at that point, cosine at 3 pi is -1. Okay, so you guys all good with that? Cosine at 3 pi is -1. Let's go back here. Go back here. All right, this is -1 times 2 square root of 2 pi. There we go. So that's going to be A. Okay? Now, in class, I told you guys to skip number 9. Silly me, we actually can do this. I'm going to teach another way to do this one, but we actually can do it. I'll just show you real quick. If you want to skip it, you can. But look, this is another way. This is an alternate way of saying the limit as h approaches 0, f of x plus h minus f of x over h. So I kind of an alternate way of saying that because it's still a slope, and it's a slope as I get really, really, really close to 0, and 3 minus 3 gets really close to 0, and that's h. That's like the part in between it. So it's just an alternate way of writing this derivative formula. So you guys read that as the word derivative. If f of x equals ln of x, what's the derivative of that? Well, that's pretty easy. You guys all know that. Okay? The derivative of ln is 1 over x. Now, what does this mean right here? As x gets really, really close to 3. So the derivative at 3 is going to be 1/3. So that's a little bit tricky. That's not going to necessarily be on your test, but it could be on, the AP test or something. It's just an alternate way of writing f of x plus h minus f of x over h. All right, I just didn't necessarily see that immediately. Cool. All right, moving right along. Okay, now this should actually say A, B, and C. A, B, and C are functions, okay, not constants. They're each a different function, and we want to find the derivative of this, all right? I know that there's a question on your test very, very similar to this. Okay, so make sure you guys are cool with this. Guys, this is going to be a quotient rule with a product rule inside, okay? Now we're going to start with the quotient rule because that's like the bigger thing that we're doing, and if you wanted to write it like as in derivative of top times bottom minus top derivative of bottom over bottom squared, and just like start filling stuff in, you can totally do that. All right? Okay, so let's go. derivative of the top. Well, the top is a. It's a function. It's not a constant. It's a function. Okay, what's the derivative of a? A prime. Right? Times the bottom. The bottom is BC. I didn't have to do anything to that, okay? And then the next part goes the top. Now the top is just A, and then the last part is derivative of the bottom. Now this is where it gets a little bit tricky, because I'm going to do it in like a different color, because it's like practically a different problem. How do I find the derivative of the bottom, which is B times C? I do a product rule, okay? I'm going to do this off to the side, and then I'll go ahead and plug it in my quotient rule. And it's going to go like this. Derivative of the first times the second plus first derivative of the second, okay? So I can put that in here. So I can go B prime C plus BC prime. And then it's all over the bottom, BC squared. All right? There's a very good chance that that is just exactly how your answer would be written. But here's like another way that you could write it. This is smaller here. Okay. I could write it like this. A prime BC, that's what's on the top. Okay, I could distribute that. That would be A B prime C. When you distribute the A, you got to distribute the minus as well. Minus A B C prime over BC squared. So it looks a little crazy, but you just have to do a quotient rule with a product rule in it. All right? Okay, nice. Let's take a look at number 11. Fourth derivative. Dang, that sounds fun. Fourth derivative at 0. Okay, here we go. First derivative, bring that down in front. 4 and then 2x plus 1 to the third. But then I got to do chain rule. The derivative of the inside is 2. Okay, let me just like rewrite that nice and make that an 8 before I move on. Okay, second derivative. All right, from over here. Let's see. Bring that down in front. That's going to be 24 2x plus 1 squared times the derivative of the inside. So let me go ahead and call that 48 times 2x plus 1 squared. All right, third derivative. Bring that down. Okay, oh gosh, 48 times 2, 96 times 2x plus 1 to the first times 2. Okay, so another way to write that, gosh dang it, 96 times 2, you guys. It's basically 180 and 12, it's like 192. All right. Now, the last derivative, there's two ways you can do this. You can continue doing this chain rule thing, but what you need to remember is if you do that, that's going to go to 0. Okay? So, like, the fourth derivative is going to be 1 times 192, 2x plus 1 to the 0 times the derivative of the inside. Okay? Well, 2x plus 1 to the 0 is just 1. And 192 times 2, I'm going to guess it's 384. Yeah, it is. It's 384. So that's my fourth derivative, okay? Numbers got a little big on us there, but not too bad, right? Okay, sweet. Let's see. As soon as you see the words equation of the tangent line, as soon as you see those words, okay, you're immediately going to write y minus y1 and x minus x1, okay? Ooh, nice. It gave me a point, which means it gave me both x1 and y1. That's very helpful. All right, so it's going to be y minus -1 and then something x minus 1. And you guys know y minus negative, we can just make that plus. So how do we find m? M is specifically the derivative. And then we plug in x. Where's my function? Okay, right here. Oh, goodness. All right. If I'm taking the derivative of that, you guys, I need to do a product rule. Okay? Whew. All right. Derivative of the first times the second. Plus first times derivative of the second. Now, when I go to do derivative of the second, it's going to be 3 times 1 minus 2x to the 2. And then I still got to do chain rule on there. I got to multiply by negative 2. All right. Now, you might be thinking, oh my gosh, this is going to be a pain to try to simplify all this. Like, it's really not, because we're plugging in a 1. Okay. So you could actually plug it in right here, but let me make this look a little bit nicer. Okay. 1 minus 2x to the third. Let me combine all those. It'd be minus 6x, 1 minus 2x squared. Now I'm going to plug in x is 1. 2 times 1 is 2. Minus 6 times 1. 1 minus 2 squared. Okay. 1 minus 2 is negative 1. Negative 1 to the third is negative 1. 1 minus 2 is negative 1. Negative 1 squared is 1. So I have negative 1 minus 6 times 1 times 1. So I have negative 7. This isn't any of those, which means I would have to like distribute it and find the answer. Except that, I mean, if I'm right so far, you know, the only one that even has a slope of negative 7 is that one. Okay, but we can do this really quickly just to make sure. If I distribute that, that becomes negative 7x plus 7. And then when I subtract the 1 over, y is negative 7x plus 6. Okay, so that's another one that's a little bit, it's got like a few, like a lot of steps, okay? Okay. Now, for 13, we are looking for the second derivative. All right? Looking for the second derivative. And so I'm going to go ahead, let me write this down here. And let's get ready to start taking some derivatives. Now, the derivative of cosine is negative sine. And then I have to take the derivative of the inside. Okay, let's talk about this for a second. X over 2 might seem a little bit confusing to you. Let's do something over on the side here. If I have a function that's x over 2, do you guys agree that it's kind of the same thing as 1/2 x? Just 1/2 x, right? And the derivative of that, so the derivative would be 1/2, because when you have like 4x, the derivative is 4. When you have like 10x, the derivative is 10. Okay, so 1/2 x, the derivative is 1/2, so this is going to multiply by 1/2. That's my first derivative. Let me simplify this out a bit before I move on. So that's going to be negative sine x over 2, because the 2 and the 1/2 cancel out. All right, now it's time to do my second derivative. Well, the negative stays there. Derivative of sine is cosine. And then because of chain rule, I'm going to multiply by 1/2. Okay, so I would probably write this as negative 1/2. I'll just move that to the front. Cosine x over 2, which is right there. All right. Okay, nice. 14, we said, was just C number 7. The exact same question that was already on there. All right, let's take a look at 15. Okay, you guys, we need to either use a quotient rule or a chain rule. Well, look, because the only x I have on the bottom, I'm going to use a chain rule. I'll write my original problem like this. 3, 4 plus x squared to the negative 1. All right? Now, my derivative is going to be, you can call it y prime or dy dx. I guess I'll use dy dx here. All right, negative 3, 4 plus x squared to the negative 2. So do the derivative of the outside, leave the inside the same. And then derivative of the inside. Okay, the derivative of 4 plus x squared is 2x. Okay, so I'm going to combine those. It's going to be negative 6x. And then on the bottom, so below where I have room, I'm going to say it's 4 plus x squared squared. Be careful. I almost just said, ooh, it's that one. Be very careful, especially when it comes to like negatives and stuff. You know, my negative is out there. That's going to be a. Okay? All right. Okay, for number 16, we're definitely going to be using our trig chart for this. All right. If x is sine x, let's first do f prime of x. Well, derivative of sine is cosine. There's no weird chain rule, product rule, or anything there. But now I need to plug in pi over 3. So I just need to know what cosine of pi over 3 is. Guys, if you have your chart, so easy. I just go and I look for cosine of pi over 3, and I get 1/2. Okay? So this is going to be 1/2. All right, 17. We're doing an f triple prime. Let's go. Okay, my first derivative is 5x to the 4th times 9x squared plus 14. Or sorry, minus 9x squared plus 14. I don't know what is it. My second derivative is 20x to the 3rd minus 18x, and then that goes away. And then my third derivative is 60x squared minus 18. So what I'm trying to do now is the third derivative at 1. Okay, so I'm just going to plug in 1. 60 times 1 squared minus 18. 60 minus 18 is 42. All right. Let's see, for 18, I'm doing a second derivative. These ones are getting like a little bit easier. Thank goodness. All right. dy dx. Derivative of sine is cosine. The derivative of x squared is 2x. d2y dx2. So my second derivative. Derivative of cosine is negative sine. The derivative of negative 2x is negative 2. That's going to be my answer right there. Okay, now let's talk about, we'll do these 3 real quick. We'll talk about some trig stuff, and then I think I'll do the free response on a different video. All right, here we go. Okay. The derivative of secant is secant tangent. And I want to find the derivative at pi over 4. So I want to know what is the secant of pi over 4 and the tangent of pi over 4. Okay, so let's go to my chart. All right, you guys. Let me write it down here real quick. Secant goes with cosine. So if cosine of pi over 4, when I look, that's square root 2 over 2. Secant of pi over 4 would be 2 over square root 2. Cosine and secant are reciprocals. So it's just going to do the reciprocal. And then tangent of pi over 4, well, shoot, that's right in my table. Tangent of pi over 4 is 1. Okay? So let's go back. This is going to be 2 over root 2 times 1, or 2 over root 2. Now, I've told you guys you do not have to rationalize, and you don't. But if it's multiple choice and they make you rationalize, just make sure you remember how to do this. So that it could also be 2 rad 2 over 2, which cancels out, and it's just rad 2. Okay, so you could put either of those for your answer, but it might only have the rationalized one if it's multiple choice. Okay, cosecant. Here we go. The derivative of cosecant is negative cosecant cotangent. So I need to find negative cosecant of pi over 3, cotangent of pi over 3. Okay, back we go to the chart. Let's see. All right. Well, before I can find cosecant pi over 3, I need to know what sine of pi over 3 is. From my chart, sine of pi over 3 is rad 3 over 2. So cosecant would be 2 over rad 3. And then I need to know cotangent of pi over 3. Well, cotangent, you guys, is the reciprocal of tangent. If you forget, all these are on that trig identities page I gave you, right? So this is tangent of pi over 3. Again, from my chart, tangent of pi over 3 is root 3. So this is 1 over root 3. Okay? So cosecant is 2 over root 3. Cotangent is 1 over root 3. All right. Cosecant is 2 over root 3. Cotangent is 1 over root 3. So this is going to give me negative 2 over square root 3 times square root 3 is 3. So negative 2/3. Beautiful. All right, let's check out 21. Okay, so the derivative of secant is secant tangent. So I want to find f prime of pi over 6. So it's going to be secant pi over 6, tangent pi over 6. Okay? Secant pi over 6, tangent pi over 6. Back to the chart. All right. Get out of the way here. Get out of the way here. Okay, secant tangent. All right. In order to find secant, first I'll do cosine. All right, cosine of pi over 6 is rad 3 over 2. So secant is 2 over rad 3. Okay, I'm just flipping it with the reciprocal. What was it? Oh, secant tangent. Tangent is on my chart right here. Tangent of pi over 6. Now I can use either one of those. I go ahead and use 1 over root 3. So it's 2 over root 3 and 1 over root 3. We just did this, okay? So 2 over root 3, 1 over root 3, which gives me 2 over 3. All right? Okay, so I'm going to go ahead and finish up this video right here because it's a little long already. And we'll start up a new one to do these 2 free response questions. Let's go.